Hello, everybody, and welcome to my presentation. It's about mechanics on our thing here. And then with the abstract of our actual mechanics, with the history of it, it is a great part of mechanical engineering of the mechanics world of the calculus. It pretty much started around the time of Aristotle, but later on in the future, it did been a lot of his stuff have been proven wrong just because around when it first came out, we knew so little of the stuff he came up with. And then from there, around the third century BC, Archimedes, who also contributed so much to it by inventing so many machines to help prove some of the things correct and incorrect of Aristotle, around the time of Aristotle. Then another time, many more breakthroughs came around the time of Galileo, many with his and Newton's concepts and principles. It now is being used many times profoundly in the world, especially in the mechanical engineers. And then in the picture to the right, you can see Galileo right there. And then with the real world application, I chose a hydraulic jack just because it helps with, or it goes with the actual question I chose. It's used to be able to lift a car off and up over the floor. It's used to it has chambers and pistons and valves inside, and then when you raise them or pump the bar, it moves fluid in and opens valves and moves pistons, which causes the actual car to go up. And then when you release it, the pressure, it pretty much does the exact opposite, or pretty much does reverse and just pushes the fluid back over into the other chamber, and which lowers the car as well. And then with my problem, it shows a dash pot, and a dash pot is pretty much a mechanical device, a damper which resists motion via viscous friction. The resulting force is proportional to the velocity and acts in the opposite direction. And as you can see in the picture, there's a piston inside the chamber with the rod that goes up and down and move the fluid and stuff like that. And then with the question, finding the average value, the retarding force symbolized in the dashpot by the accompanying figure slows the motion by the weighted. So the mass position at the time t is the y is equal to 2e negative t cosine t from the interval 0 to 2 pi. And then from there, created a graph as a prediction or estimation, moving from increments from 0.2 and then going all the way to 6, seeing how it goes down and goes really, really close to 0, but not hitting exactly the 0 to 2 pi. Then with that, we're going to use the average value for it, which is the formula here. And then having to choose the actual stuff we need to go, like the F is the E negative T cosine T, A is equal to 0, B to 2 pi. From there, you just pretty much plug it in, just drop it in, which gives us this guy right here, the 1 over the 2 pi minus 0, 0 to 2 pi, 2e negative t cosine t dt. And you just pretty much simplify it then and there. And then from there, we had to look up the this formula going in from another one, from the integral table of integrals number 115 from the exponential and logarithmic formulas. And then once you plug it all in again, 2 over 2 pi e over negative t with over t squared plus 1 squared negative cosine t plus sine t. Then from there, just keep on going again. 1 over pi e over negative t over 2 sine t minus cosine t with 0 and 2 pi. And then when you plug those guys in, it gives you the 1 over 2 pi minus e negative 2 pi, 0 minus 1 minus 0 minus 1 again, which gives us the actual true value of the actual question, which is the 1 over 2 pi, 1 minus e negative 2 pi. And then once you plug that into the actual calculator, because it's a best friend of ours, it gives it a 0.15886. And that's it.